Hi everybody, welcome to our fourth tutorial on learning the program with Roblox Studio. And this is our third tutorial in progression that will go over the final element you need to build any program you want to build. In our last two we went over sequence and selection. Sequence being performing your instructions or code into the computer in sequential order so you get the right output. Selection being the choice between two sets of instructions to make, and based on a conditional. And you can follow along and learn about those in our previous tutorials, part 2 and 3. On part 4 here, we're going to go over our final third one. As mentioned before, we're going over repetition. So the three building blocks are going to be sequence, selection, and repetition. And repetition is going to be performing the same set of instructions repetitively while a condition is true. And how we go about doing that with or telling the computer how to do that. How do you keep running a certain set of instructions over and over again? Which instructions? Well, there's what a lot of programs call loops, and they are basically the programming structure for repetition. And there's many different types of actual loops you can make in code. Today we're just going to go over the first one, and that's going to be the while loop. In the while loop, it runs a lot like the if loop, as we went over in our previous tutorial in part 3. The difference is that after the conditional on the if statement, the statement block will run, and then you'll go outside of that statement or that programming structure if and hit the next statement. What that means is a while does not do that. A while will continue to run inside that statement block. And I'll kind of go, it's kind of hard to see without visual, so I'll go ahead and we'll start programming our first loop together. And what we'll do to start is, just like the if statement, we're going to need a conditional. And just like the if statement, our conditional will be evaluated to see if it's true or false. And so we can start the same way. We could say, well, this time we'll start with, say, we'll go with a x as a variable, and we'll assign it to a number this time, say 1. So x receives 1. Okay, now we'll set up the set of instructions to let the computer know to run something over and over again. Run a set of instructions over and over again. How we'll start with that is we'll start with our while loop, and after while, just like the keyword if, we're going to need to set up a condition or a conditional. And how we do that is we set up a condition that can be evaluated to true, just like we would with if. And in this instance, what we're going to do is we're going to evaluate for a value in x. So we have 1. But what one of the conditional operators we can use that we haven't been seen yet is less than. And this open bracket less than, which points and means is read out as the value of variable x is less than, and then say let's put a random number 6. So this is going to be read as the value in variable x is less than 6. And as we can see, the value we put in x is 1. So what you'd see here is 1 is less than 6. And that would evaluate to true. The computer would basically do the math on that, check it, and say, yeah, 1 is less than 6. This condition is true. So it's going to go and want to do, and that's the next keyword in the structure of the while loop. And as you see, once we do that, we get our end here. And again, as I mentioned previously, when you see that, it should trigger you to know that there's going to be a state that you can have a statement block between here. And as programming convention goes, you want to have an indent and then put your instructions in here. And it could be one instruction, just a single statement, or you can make another set of instructions or another instruction, and together be known as a statement block. And it could be the statement block can be 2 or more. And each single line is known as a statement that gives one instruction. So, okay, now we've set up our first while loop. And what it does, okay, so how is this any different than the if? Well, it's very similar in structure, right? We have our keyword, and then we have to set up a conditional, and then instead of then, we have do. But then we notice we have our instructions, almost just like we set up an if statement. The difference lies in what happens after the last instruction in the statement block is ran. And it can be the last instruction if it was just one statement, or a statement block. So what that means is, say instead of just part instruction, I put like print A, and I put print B after that. I have two statements and a statement block that prints A and B. So after it says print B, what's going to happen is it's going to go back to line 7. And okay, well, why does it do that? Well, it's going to evaluate the condition. It wants to evaluate the condition again to know, should I run these set of instructions, this statement block again? And if this statement, or if this conditional evaluates to true, then these sets of instructions will be executed again. And so since we have nothing that's going to change the variable x, it's going to keep running. There's nothing to stop it. So it will always evaluate to true, right? There's nothing, if 1 will always evaluate to less than 6. So it will run. It'll get to line where it says print B, the statement, line 9. And okay, it'll go back once that statement's ran. Right after it's completed, it'll go to line 7 and check again, should I run again? And it's always going to say yes, so it's going to be over and over and over again. And they call that an infinite loop. So what happens if it doesn't, it doesn't evaluate to true? Well, what would we have to do here to change it so it would evaluate to false? We would have to change our variable, right? So say if we plugged a 6 in here instead of a 1, so we make the variable 6, what would happen is it would stop. And I'll actually go ahead and show you that, because I didn't show you that before. This will run forever, and what I have to do, because I have to add a wait statement, because it'll lock up my computer, because this is a very powerful programming structure, and when you want to do something over and over again, computer wants to do it immediately. And when you write infinite loops, sometimes you can bog a computer down. You'll notice games with lag. You might have a loop issue there, or a repetitive issue. So I'll add a wait here, and what we'll see happen is an infinite loop that prints A and B over and over again. And you can see the output down here, AB, AB. Every 3 seconds, it's going to spit out AB, AB. And it's going to do that forever without end. So what if we wanted it to end? Or what if we wanted to end after, say, five turns? So what we do is, if we're not having an infinite loop and it's not doing too many iterations or times through the loop, that we'd say we could change our variable. So every pass, what if we did every pass we added 1 to our variable? So the first iteration, the first time through the loop, it would be 1. And when it got to the end of the statement block, we'd change the value in x. So we'd say x equals x plus 1. And again, anything to the right of the assignment operator is going to be evaluated, which means we're going to do the math on it. So the value of x is really 1, so 1 plus 1 is 2, and that evaluates to 2. 2 gets assigned the x, and we kick back to line 7 again for the statement. And since x is now 2, the value of x is now 2, is 2 less than 6? Yeah, it is, so it's going to do again. And now we're going to have to evaluate on the second iteration, or second time through the loop, it's going to be 2 plus 1. That's going to evaluate to 3. So x is going to be assigned 3. Is 3 less than 6? Yes. And what I can do here is, instead of a and b, I can actually print out, x, and you can see that what the value of x is each time through the loop. And we could say x before change, x before change, it was changed, and we'll have x, and we could just copy that. And if we put a line here that goes x after change, we can see what's occurring with x before we do the addition and after we do the addition. And we can also do a iteration count. You know, how many times was it ran, if we wanted to, just by using the counter. So what we can do now is hit play, and we'll see. Oh, add an extra comma there, but you can see that on the first pass we have x before the change is 1, after the change is 2. Second pass, before the change is 3. So you can see here on the last pass, x equals 6, right? And that's the after change. So on our 1, 2, 3, 4, 5th pass, we'll have x equaling 6. And then you see nothing happens after that. Why is that? Well, once x is equal to 6, this gets evaluated again. And 6 is not less than 6 in the computer's eyes. It's equal to 6. So that will evaluate, that expression or conditional will evaluate to false. And because it's false, like an if statement, it will not run the statement block. It will then proceed to line 12, whatever is on line 12, or if it's blank, line 13. And the code will progress from there. So like the if conditionals, if it's false, it will not run the statement block, and you will get placed on the next line to execute in your code after the statement blocks and the structure you're on. This would be the looping structure. So now what we can do is we can test, okay, well, since now I know that, well, what would happen if I made this 6 immediately? Would anything print? I took that out, so let me add that back in. Will anything print at all here? Oh, let's find out. So we change our initial value of x to 6. So the first time this runs, we're going to hit the while loop on line 7, and it's going to evaluate, is 6 less than 6? Going to be false. Will it even run the first time? Let's find out. Hit play. And wait a second, and we see nothing. Nothing prints. So what that means is you can create the structure in the loop that prints any amount of times you want based on this conditional. It could print, or it could run the statements in the statement block 1 time, 2 times, 3 times, 4 times, and as we've seen here, 0 times if it's not set up correctly. And now we see the importance of this is that it can perform tasks over and over again, and as before on our if statement, it only runs through once. So once that condition is found true or false, okay, do this, and then that's the last time you're ever going to see that again. With a while statement, the difference is that it can keep doing that. Now, why is this important? How does this relate to anything we've done so far? Well, if you remember back to the street lamp in tutorial 2, or we had our sequence, we were running through the importance of the building block or the building structure and programming of sequence, that our street lamp example, or street light, it only ran once, and we could only get it to do once. It went from green to yellow to red, And what I'm going to show you now is that with this new tool in your tool belt, you can get a street lamp to run continuously. So if you were in a game or building an object that wanted to do something continuously, now you have the ability to do that. And I won't go over too much of the basics of how we set it up. You can go through back to tutorial 2. But as you can see, I have a red, yellow, and green light. Those are cylinders, and another cylinder is a base and a part, and those are anchored. And what I want to do now is we can work together to create the street light that'll turn the lights on and off in sequential order, but over and over and over again to infinity. So how we'll do that? Let's comment this out here. So again, anything commented out is ignored by the system, and the first line to be executed will be line 12, as we're going to start writing our script there. So, or the first line of our script there, and we'll start with the red variable, and we'll set that to the red object. And this is, again, if this is you're not understanding this part, you may want to rewatch tutorial part 2. This goes over more of setting the variables to actual objects in the game, and that's all we're doing here. And we basically want to set a variable for each of the lights, so we have quick access to them, and we can change their properties right away in the code we're going to make. So what I'm going to do is we have our light set up, and now basically we're going to run that same script we wrote on in part 2, but we're going to run it between our newly learned while loop. And how we're going to do that, we want it to run forever. So the simplest way to get something that you want to run as an infinite loop forever and ever is this form. You're going to say while, and the simplest way to say true, or to have something always evaluate to true, is just to say true, while true. And as you can see, there's no variables with it, so there's no way it can change. There's no way to change this. So what's going to happen is anything in the structure, or any statements in this loop structure, are going to run continuously, line by line, instruction by instruction, and then back to the top instruction, instruction by instruction. So as we can see here, we're going to start setting that up. So we want to set our material, our green, which refers to the variable green, which is the value in it is the object of the green light. So we could say the object of the green light property material receives neon. And again, be cautious that you want to have the first letter capital in the material type, as the system won't understand a lowercase n. This will not be understood. So you want to have the first letter capital, and neon and plastic, as you see going forward, we're going to use as an example here. So we're going to wait 3 seconds, then we're going to turn the green light off by using, again, a first letter P capital, plastic material type. And immediately after, we want to turn on our yellow light and set that the neon to do that, and we want to wait again. So as you can see, even in our example, we have some repetition going on here. So there's probably going to be a way to set this to where you can get rid of it using a looping structure like we're doing. But for example's sake, we're just going to run through and do it this way. Not too bad, actually. And we're going to turn off the red light finally. So what's going to occur now? From what we learned, while, okay, so we're going to run through our conditional. Once the code reaches line 16, it's going to check true, and that's always going to be true. So we're going to be entered into what's known as an infinite loop, which means these sets of instructions are going to run forever until they either kick an error or the program stops. And what does that mean? That's also a pitfall for you to watch out for. If this runs forever, you really don't want to add code below there, right? Because this is never going to extinguish, which means it's never going to continue on. So if I say print A as a instruction after this loop structure, it's never going to print A because it's always going to be performing these instructions, right? So it'll never get to this, and that's a pitfall to watch out for when you do loops that run forever. Or if you're wondering, hey, you make a loop in your code, and hey, this stuff after my loop's not running. What's going on? You want to make sure your loop or your repetitive structure is eventually ending. Otherwise, everything after this will not be run. So that's one pitfall to a loop. There are pretty much there's several more to look out for. We'll go over those. We'll have further tutorials on all the different types of loops. But for now, we have the true, evaluating the true, creating your infinite loop. And so it'll run through each one of these instructions one by one until it gets to the last one. And then it will go back to line 16 to the while and evaluate the conditional. True, and we have the same thing occurring over and over again now. So what will that look like in our studio with the street light? Well, let's hit play. Let's play here and find out. Oh, there you go. So our green light's going, our yellow light's back on, red light's on, everything else is off. So as you can see now, unlike we had in our tutorial on sequence, the lights continue to flash in sequential order over and over again. So that's the power we have with our repetitive programming structure, is that we can perform the same task over and over and over again without having to write over and over again. How we would have to do that before without knowing of loops would be to take that sequence, copy, paste it a million times, which is very, very poor, very poor structure. So now we have something that can run the same set of code over and over again to infinity. So it prevents you from having to write those out, and that's pretty powerful. So now you have all three of the basic building blocks for making any program you want. Theoretically, you could make anything you want to make. There's a few more things you're going to have to learn. We'll go over in our future tutorials, but you're on your way to knowing the basic structures of everything you do want to know. And it's really now comes to a bit of creativity as you go forward, of trying to figure out how I want to solve this problem and what code do I want to write. But other than that, you are aware of the basic elements you need to create any program you want to make. And as always, you want to subscribe and click the bell so you receive notifications. We do put out, or I do put out videos every so often, new tutorials, and if you want to get on top of those and get all those early and get notified, please subscribe and leave a like, and make sure you have that bell clicked. Thanks. Have a good day.